Okay, so we're continuing our looking at the different ways to prove triangles congruent. Remember in the last video, the last lesson, we talked about the SSS postulate. In this one, we're going to be talking about the SAS postulate, which is very similar. It's the same sort of thing. It's just a different way to prove triangles congruent. All right, so the SAS, or the side angle side postulate, says that if two sides and the included angle, and that's an important part, the included angle, between those sides of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So I put a couple of pictures here below that just to show you what it means by included angle and how this postulate actually works. If you notice in the first picture, remember our little sort of our standard way of saying sides are congruent. So one tick and one tick means that those two sides are congruent, and then these two ticks and these two ticks say that these sides are congruent. And what we mean by the included angle, in order for it to be side angle side, the angle has to be between the two congruent sides. So we have a side angle side, side angle side. So these two are congruent by SAS. Contrast that with this picture, and we have two sides and an angle congruent, but the angle isn't between those two sides, and because of that, it's not congruent by SAS. So the SAS only works if the included angle between those two sides are congruent. All right, so let's look at a couple of examples. In this example, basically, all we're asking is what info would you need to prove the triangle's congruent. So let's look at number one. So we have triangle LGT and triangle MNQ, and we have LT is congruent to MQ. And then notice this little, sort of like this little semicircle here, that says that those angles are congruent. And we do that sort of the same way that we do the tick marks. If there's one little semicircle on each, that means that those two angles are congruent. So let's say we had something down here with triangles, and I know they don't look alike, but let's say we had this angle and this angle congruent, but let's say this angle is not congruent to that one, but it is congruent to this one. The way we would write that is we put two little semicircles there. So it's just a standard thing in geometry, sort of to help us label a picture and see it as a picture instead of trying to write it all out in words. Anyways, we have a side and an angle and an angle. The info that you would need to prove these two triangles congruent, you would need this side to be congruent to that side. So the answer to this would be you would need LG to be congruent to MN. All right, simple enough. Look at the second one. Take a second and see if you can figure out what info you would need to prove these triangles congruent. Notice in this one, there's two different things that would make these triangles congruent based on what we've learned. So take a second, look at that, and then come back and I'll explain. Okay, so if we want to prove these triangles congruent by the side angle side, or SAS, we have to look at, well, this side is congruent to this side, this angle is congruent to this angle. Then what we would need to prove that this side is congruent to this side. So in order to prove it by SAS, you would need RS to be congruent to UW. That's for SAS. And also, if you notice, by making RS congruent to UW, we can also prove them congruent by the SSS postulate. So there's two different ways to prove that congruent. Fortunately, they are the same two pair of sides. So that's the SAS postulate. If you have any questions, please bring them to class.